So at this point in our configuration, all devices know about the layer 3 multicast configuration, and the time's come for us to be able to create these VNIs. Now I want to remind you guys of some things. Show run interface loopback 100 is going to be the interface that we're going to use for our VTEP. So what I'm going to do is I'm going to say interface loopback 100, and I'm going to say description, and over here I'll just simply say VTEP address. So all I'm doing is just labeling it what it is. So the way that we do this, first of all, we're going to have to say feature NV overlay, and then feature VN segment VLAN based. Same thing over here, just so I don't forget. Config T, we will say feature NV overlay and feature VN segment VLAN based. So now we're ready. This gives us the ability to create the NVE. So interface NVE1. I'm just going to go ahead and say no shut. And when we look at what our configuration values here is, remember we mentioned the fact that we were going to use loopback 100. So the way we're going to do this is we're going to specify a source interface of LO100. And then what we're going to do is we are going to configure the system such that we're going to define the member. Now it says NVE VN segment membership. So if I say member, you'll notice that I get the ability to be able to specify a VNI, and I said that we were going to use 10100. And I'm going to assign this to the multicast group of 239999. I will say no shut. Now what I need to do is interface NVE. I think I already did it. No shut. Now what I want to do is I need to go to VLAN 100, and I'm going to say VN segment 10100. And all that did was create the VLAN that I'm going to be using and assigns it. Now I'm in virtualization right now, and I am not going to be using IGMP snooping or HSRP over any of the VXLANs, so I don't really have to worry about double wide ARP Ether configuration for my ternary content addressable memory or my TCAM. So I'm just going to choose to ignore it, and everything should be okay. So all I'm going to do now is do the exact same configuration on the other side. Interface NVE, we'll say 1, no shut. We will say source interface loopback 100. We will then say member VNI 10100 for, you can actually hit carriage return and then type Encap down here 239999. So you can do it as a single line or you can do it as a double line. And if you do no shut, it just basically no shuts the NVE. So it's not a configuration under the member. And then all I'm going to do is I'm going to come over here and I'll say VLAN 100 and I'll say VN segment 10100. Exit. Exit. And now what I want to do is I want to take a look at these interfaces. So I'm going to say show interface NVE1. And what we're going to see here is notice it says that the NVE is up and operational. Notice it's supporting an MTU of 9216. I didn't specify that. And the encapsulation operation that we're using is VXLAN. So Virtual Extensible Local Area Network seems to be working. Another show command that I like to do here is going to be show NVE VNI. And that's going to show the VNI association. It's going to tell me that NVE is supporting VNI 10100. It is using the multicast group of 239.9.9.9. Its state is up. Its mode is DP. And what I'm going to call your attention to here is that stands for data plane. Now, a lot of people call Flood and Learn multicast control plane. From the perspective of the VXLAN configuration on this device, it knows that it does not have a dedicated control plane, which is why it's actually saying DP. Later on in our studies and conversations, we'll actually start working with the idea of EVPN. And when we run EVPN, it will recognize EVPN as a dedicated control plane construct. But right now, just keep in mind that we're not really using a dedicated control plane mechanism for VXLAN. We're just using a multi-destination layer 3 underlay to allow devices to communicate. So what will end up happening is that as resources need to communicate and as things need to get built, we'll use this multicast group to communicate that idea or that need to all VTEPs in our environment. We're going to take a very careful look at how that works. We see here that it is a layer 2 VNI, and it is supporting the bridge domain or the VLAN of 100. When we get into more conversations about the application-centric infrastructure, some of this terminology will start making more sense as we start looking at the idea of one-to-one feature comparisons between traditional Nexus and ACI, 9Ks in ACI mode. So right now we're using a virtual 9K. In fact, if I look at the show version for everyone's edification, I think I'm running 922. Yep, I'm running NOx version 922. As far as this walkthrough, it should work perfectly fine with older versions also. So right now we see, or should see, that I have my NVE up and operational. So if I say show, run, or show interface, NVE1, and show NVE VNI, we should be good to go. And let's say I'm also look to see if I've formed a peer, because remember, this switch 9K1 or Leaf 101 is actually not directly connected to 9K2. And what I want to do is I'm going to execute a command so-called show NVE peers. I want to see who I've formed a relationship with, and what we'll find is that at this juncture I have no NVE peers. That's not something that I want us to become concerned about, because we really haven't formed an adjacency between any of the resources that we're using in this lab as of yet. And what we're going to do in the next video is actually remedy that. What we're going to do is we're going to fire up those hosts, and we're going to generate some traffic between host 1 and host 2. And then hopefully, if everything goes well, we should see the traffic goes across this layer 3 infrastructure by the formation of that tunnel that's going to be sourcing from Leaf 101 all the way to Leaf 102. And then when that happens, we should actually be able to see an NVE peer. So I look forward to exploring that in the next video. I'll see you guys there.